Good day, everyone. I am John Daryl Agbas, and today I'm going to teach you the basic differentiation rules so that you will be able to answer problems involving derivatives. So this is an overview of the topic that I'm going to be discussing. First is the constant rule. Second is the power rule. The third rule is the identity function rule. The fourth rule, the constant multiple rule. Number five, the sum or difference rule. Number six, the product rule. And the last one, the seventh, is the quotient rule. But there are many differentiation rules. So what I'm gonna discuss you are just the basics of it. Okay. So first we have here the rule number one, the constant rule. So this is its formula. Let's read first the definition. If f of x is equal to c, where c is constant, then f prime of x is equal to 0. The derivative of a constant is just equal to 0. So don't be confused with the formula, okay? So let's say this letter here, letter C, represents any constant. Let's say, for example, any integer, may it be positive or negative, may it be 8, 1000, or anything that is a constant, okay? To give you an example, let's have an example number one, y is equal to 5. Okay, the derivative of 5, what is 5? 5 is constant, right? So the derivative of y is equal to 5 is equal to 0. Okay, example number two, y is equal to 1000. The derivative of 1000, what is 1000? 1000 is not a constant. Wait, how can you tell a thing that is a constant or not constant? I can say that it's a constant if it's not associated with any variable, okay? Since 1000 is only 1000 and it's not associated with any letter there is, so this is a constant. So the derivative of a constant is 0, okay? Example number three, y is equal to 5 pi. 5 and pi. Is pi a variable or not? Pi is not a variable. Pi is a constant. Pi has a value of 3.14. Okay, so don't be confused with that. Pi is a constant. So the derivative of 5 pi, since both are constant, so that's just equal to 0. Example number four, y is equal to square root of 7. Don't be confused with the any radicals there is if a constant is inside a radical or a square root symbol, since 7 is a constant, so the derivative of square root of 7 is just equal to 0. And so that's it for rule number one. Let's proceed to rule number two. We have the power rule. So this is the formula of the power rule. Let's read the definition. If f of x is equal to x raised to n, then f prime of x is equal to n times x raised to n minus 1. Okay, now the formula might be confusing, but let's discuss it so that you'll better understand. So let's say, for example, we have here x. X is any variable, not a constant, but a variable. Any letter there is, may it be x, y, z, or anything that is a variable, okay, raised to a power, to an integer. So you will use the power rule to differentiate the function. So the formula says that you have to bring down n. N is your power. You have to bring down it, and you have just to copy the x raised to n, but you have to subtract 1 from your exponent. To better understand, let's have an example. Example number one, y is equal to x raised to 4. X is a variable and a variable raised to a power, so we will use the power rule. According to the power rule, you'll just have to bring down the power, right? So here's the power, then bring down, then you have to subtract 1 from your power. So, okay, to do that, the derivative of x raised to 4, just bring down 4. As you can see in here, I just brought down 4 beside the variable x, and I just subtracted 1 from the exponent, just like from the formula we have in here. Bring down the 4, which is a power, and subtract 1 from your power. And to further simplify that, 4x raised to 4 minus 1, that's just 4x raised to 3 or 4x cubed. So that's it. That's your answer. Okay, example number 2, to further understand, we have y is equal to x raised to 6. X is a variable and 6 is its power, so according to the power rule, just bring down the power. What is our power? 6 is our power. So we just have to bring down 6 beside x. Okay, so as you can see, it's 6. Then copy the x raised to 6. Then you have to subtract 1 from your power. To further simplify, we have 6x raised to 5. Okay, that's simple. Third example, we have y is equal to square root of x. Now, this is different from my example before, which is the square root of 7. Since 7 is a constant and x is not a constant, x is a variable. So let's differentiate this one. So we can write it in its exponential form, which is x raised to 1/2. This is just the same as this square root of x, okay? Any radical there is, you can rewrite it in its exponential form. So this is its exponential form. And since we have a variable in here and a power, so let's do the power rule. We just have to bring down the power. What is the power? 1/2 is our power. So 1/2 times x raised to 1/2. And then we have to subtract 1 from our power. Easy, right? Just don't be confused, even if it's fraction or whatsoever. So to further simplify, 1/2 times x and 1/2 raised x raised to 1/2 minus 1. 1/2 minus 1, that's just equal to negative 1/2. And that's your answer, but you can still simplify it to eradicate the negative exponent. Uh, okay, you can rewrite it as, since you have a negative exponent from your numerator, to make it positive, you can bring it down to your denominator and changing its sign. So that's why we have here x raised to positive 1/2, since we transferred it into our denominator. That's why the sign must also change. Okay, so this is our final answer. We can rewrite the exponential form into its radical form. So this is the final answer, 1 over 2 square root of x. As example, y is equals to 1 over x squared. Okay, I just transferred x squared to the numerator, changing the sign. That's negative 2. And then doing the power rule, we have bring down negative 2 and then subtract 1 from your exponents. Since both are same sign, you'll just have to add it. So negative 2x raised to negative 3. Or negative 2 all over x cubed. Okay, that's it. And let's proceed to the third rule, which is the identity function rule. So the identity function rule is just really simple. If you have a variable, let's say, for example, you have a variable x, the derivative of a variable, that will always be equal to 1. Okay? So example number 1, we have y is equal to x. Let's find its derivative. X is a variable, and then according to the identity function rule, the derivative of the variable is always equal to 1. So derivative of x is 1. That's it. That's the rule number 3. Let's proceed to rule number 4, which is the constant multiple rule. Okay, the formula might be confusing, but it's simple if you truly understand what I'm talking in here. Okay, let's read the definition. If f of x is equal to c times f of x, where c is constant, then f prime of x is equal to c times f prime of x. Okay, the definition is also confusing, so let's proceed to the example to better understand. Okay, y is equal to 5x raised to 8. So according to the constant multiple rule, if you have a constant, where's your constant? 5 is your constant, right? And then you have an exponent, an exponential variable, which is x raised to 8. If you see it like this, you'll just have to retain the constant, that is 5. Okay, the 5 is retained, and then you'll just have to do the power rule, which I talked about a while ago. You have to bring down 8, which is your exponent, right? So that's why we have 8 in here, and then we have to subtract 1, and then simplify. That's it. 8 times 5, that's 40. X raised to 8 minus 1, that's 7. So that's the final answer. And then example number 2, we have y is equal to 4x cubed. So the constant multiple rule says if you have a constant, beside of any variable, you will just have to retain the constant. What is your constant? Your constant is 4. So 4 will be retained, and then doing the power rule, we have to bring down 3. That's why we have 3 here from our power. I brought it down. And then you have to subtract 1 from your power. And then by simplifying, we have 3 times 4, that's 12. And 3 minus 1, that's 2. So we have the final answer, 12x squared. And that's it. Uh, Now let's proceed to rule number 5, the sum or difference rule. Now this is just really simple. You'll just have to do the differentiation and then copy the sign. It may it be uh, plus or minus. Okay, example number 1, we have 5x plus 3. Okay, we have an operation sign in here. This is the sum or difference rule. According to the formula, we'll just have to get the derivative of the first term and get the derivative of the second term, or any term there is. So the derivative of the first term, that is 5, that's constant multiple rule, right? You just have to copy the constant 5 and then differentiate the variable 1. I mean the variable x. What is the derivative of x? I said a while ago that's the derivative of a variable that is just 1. Plus, copy the sign. What is the derivative of 3? 3 is constant, so that's 0. So 5 times 1, that's 5 plus 0. So the answer is 5. Example number 2, we have 4x cubed minus 8x. Just never mind the operation, okay? You'll just have to copy it and perform the derivative. So 4x cubed, that's constant multiple rule, copy 4, and then bring down 3, which is the power 3, and then you have to subtract 1 from your power, okay? And then leaving that aside, continuing to the second term, we have minus 8x. What is the derivative of 8x? 8 is a constant, so you'll just have to retain the constant, and since it's associated with the variable, you have to differentiate the variable. X, what is the derivative of x? The derivative of x is equal to 1, so 8 times 1, okay? By further simplifying, we have 3 times 4, that's 12, raised to x. 3 minus 1, we have 2, minus 8 times 1, we have 8. This is the final answer. Okay, that's for the rule number 5. Let's proceed to rule number 6. The second to the last rule, the product rule. Okay, this is its formula. Okay, don't be confused with the formula. To further understand, let's have an example number 1. We have a term here multiplied to another term here. So according to the product rule, the first term, copy the first term and multiply it to the derivative of the second term, plus get the derivative of the first term and multiply it to your second term. To further understand, that's example number 1. Okay, according to the formula, we have to copy the first term. So our first term, this is our first term, right? So let's write it down first. We're using the formula so that we will be able to understand. So first term, we have to have the first term. This is the first term. I just copied it, okay? This is the first term. This is the first term. And then the rule says multiply it to the derivative of the second term. This is our second term, and by getting its, wait. Let's first differentiate this one. So the derivative of this one is this, right? So I will not explain further about how I got that because I told you a while ago. Okay, we have the second term, the g of x, which is this one. Copy it, and then find its derivative. The derivative of the second term is 15 squared. Now, by using the formula, it says here that you have to copy the first term. This is the first term, so we have it here, and then multiply it to the derivative of the second term. What is the derivative of the second term? This is the derivative of the second term, so that's why I put it here, and then plus, and then get the derivative of your first term. This is the derivative of my first term, so I put it here, and then multiply it to your second term. My second term is this one, so I have this. And then by further simplifying, we have then this one. You'll just have to distribute it one by one, okay, to further simplify, and you have your final answer, okay? To further understand, let's have an example number two. Example number two, okay, it's again the product rule, a term multiplied to another term. Okay, let's first get the derivative of the first term. The derivative of the first term is 6x, right? Okay, just remember what I told you about the differentiation rules a while ago so you can differentiate without any hassle. And the derivative of the second term, this is our second term. What is its derivative? Using the differentiation rules a while ago, we have this 2x minus 3. And now, by inputting it into the formula that we have, the product rule, the first term, our first term is this one, so copy multiplied to the derivative of the second term. This is the derivative of the second term that we have here. Then plus the derivative of the second term, I mean the derivative of the first term, this which is this one, multiplied to the our first term. I mean our second term. I'm sorry. By distributing it and expanding it, we have our final answer. Y prime is equal to 12x cubed minus 27x squared minus 8x plus 12. And that's the product rule. Again, you'll just have to copy the first term, multiply it to the derivative of the second term, and the sign will always be plus, okay, for the product rule, plus. Then continue the find the derivative of the second term multiplied to find the derivative of the first term multiplied to your second term. Okay, for the last example, we have example number 7, the quotient rule. So this is the formula of the quotient rule. You have your numerator divided by a denominator. Example number 1. Okay, let's first get each of the derivatives of the numerator and denominator. So let's say, for example, we have to get this derivative so that f prime of x equals 30, okay? And for the denominator, we have here got the derivative of the denominator, that's x. The derivative of x is just equal to 1, okay? By performing the quotient rule, let's use this formula so that we will not be confused. Let's input it together, okay? First is we need the second term. This is our second term, right? So our second term is x. So copy the x multiplied to the derivative of your numerator. Our numerator is this one. What is its derivative? So this is our derivative. That's why we have here. And then in the quotient rule, you have to subtract it, okay? Copy the subtraction sign and then multiply the f of x, which is your numerator, copy the numerator multiplied to the derivative of your denominator, the derivative of our denominator, which is 1, so that's why it's multiplied to 1 all over your denominator. You just have to square your denominator, okay? That's why we have x squared here. And by expanding and further simplifying, we have this one, okay? You have just distribute it out, all it out. That's why we have this one. And then combining like terms, you have this one. To further simplify, the answer is 20x. And that's it. That ends the differentiation rule. So again, this was the overview a while ago. You'll just have to memorize so that you can answer. Thank you.